What's up, everybody? Happy Tuesday. I had to make that face real quick because as soon as I go live on the camera, and then it's like everything wants to start moving. So anyway, we are live from the Alpha Esports Technology Center. We are we're doing another day of the Appsec Rabbit Hole, and so far we've covered basics of Linux, we've covered basics of Windows, we've covered DNS, we've covered how websites work or how web applications work. We've covered HTML, we've covered CSS, we've covered JavaScript, we've covered databases with SQL, and then we started looking at um, yeah, we said JavaScript. Yep. And then we started looking at some of the tools. We covered the Burp proxy and the Burp suite set of tools or report swigger. And I guess it's only right since we talked about how the web works. We talked about the main tool we would use to test web applications. So now let's talk about what we're going to test for. So today we are going to focus on the OWASP top 10 and try hack me, the try hack me path. Put the room in here if you want to follow. Um, Says it's going to take about 2 hours to complete. So we should expect that, or maybe a little bit longer, just in case I get to yapping. But everybody was here. The Appsec Rabbit Hole basically is just a collection of um, rooms in Try Hack Me that, as well as some exercises and things that I've curated and come up with a list to help you learn about the basics of application security. So, web application, mobile application, APIs, cloud applications. We'll be covering all of that over the course of the next, I don't know how many months. Um, so far, we are on day 15. And like I said, we've covered most of the basics. So now we're going to actually start getting into offensive security side of it. We're going to start with the vulnerabilities that you can go after, and then after that we'll talk about some more tools. Not today, but I'm just saying we'll cover some more of the tools, and then we'll also get into some more hands-on stuff. All right, so let's go ahead and jump into it. If this is your first time watching, I appreciate y'all. Please be sure to like the video, follow and subscribe wherever you're watching from. So we have people. Looks like we have people watching from Twitch as well as YouTube. So thank you to everybody who's watching us wherever you're watching. We greatly appreciate it. If you haven't done so already, please be sure to like and subscribe to the channel so you'll be notified every time we go live. I try to stay around. I try to stay no later than 5 o'clock before we go live, and we usually do it mostly Monday, Tuesdays, and Thursdays. Sometimes we're not able to do it on Tuesdays because we have other classes going. But Mondays and Thursdays for certain, for our tech stuff, and then as we get into our esports stuff, then we have stuff on Fridays and Saturdays as well. Um, I plan on streaming on those times, definitely those days for the foreseeable future. However, we may, as we start progressing, we may bring it down to once a week instead of twice a week. I don't know. Y'all let me know in the comments if you guys are liking the content so far. If you want to see it, if you want to see it less, if you want to see it more, or if it's like just right with two, three, with 3 times a week. Like I said, I'm thinking probably 1 to 2 times a week. All right, so let's go ahead and share our screen and get over to the OWASP top 10. So, like I said before, when dealing with web application security or application security, the first thing you want to do is make sure you're secure, right? That's the whole. It's in the name security. So the Open Web Application Security Project, or also known as OWASP, came up years ago. with the top 10 vulnerabilities that are found in most applications. And they started off with just web applications, but since then they have um, progressed, and now they have the top 10. They have top 10 vulnerabilities for web, mobile, APIs, cloud. I think I saw one for now that they're doing for AI. I mean, they have top 10 for a bunch of stuff. What's going on, Ty? So hold on, actually. While I do that real quick, I do remember I have to do a coach thing real quick. Uh, okay, sorry about that. I had to send out a message. All right, what's going on, Ty? So like I said, so the OWASP top 10 or the top 10 vulnerabilities for that time frame. So this is the OWASP top 10 that came out in 2021. I don't think there is a new OWASP top 10 for web apps. I know APIs are recent as of 2023. So yeah, so this is the most recent OWASP top 10. It looks like they'll probably be coming out with a new one fairly soon. Um, they usually come out every about 3 or 4 years or so. So just looking at the okay, so they do have two sets. Okay, so I'm looking, yeah, so try hack me. So maybe we will cover that one day. But this is the 2021 version. So you see here the top 10 vulnerabilities for OWASP for 2021 or as of 2021 is broken access control, cryptographic. Number two is cryptographic failures. Number three is injection. Number four is insecure design. Number five, security misconfiguration. Six, vulnerable and outdated components. Seven, identification and authentication failures. Eight, software and data integrity failures. Nine, security logging and monitoring failures. And number 10, server side request forgery. I'm just going to go ahead and let y'all know now. Oh boy. Oh boy. Look. Was it warranted? I mean, usually if people go off on their manager, they think it's warranted. But I'm gonna ask anyway. Was it? You know what? I ain't even gonna hold you, man. These managers and supervisors and stuff like that, man. They they be overstepping boundaries sometimes. So hopefully, you know, hopefully you're good. So so anyway, I was gonna say so number 10, server side request forgery. I have like it's a funny story with that one. Like this was like my sworn enemy for years. It still is kind of. I don't know. There's just something about it that I just could not grasp, and it took me a while to like fully understand it in a real world scenario. Um, but but anyway, we'll go ahead and cover most of this. So again, broken access control. This is, I mean, this is rightfully number one currently because you know most breaches or vulnerabilities that get exploited are due to access control weaknesses, cryptographic failures. That's that things aren't properly encrypted. Injection. So injection used to be number one, or SQL injection used to be number one, but now it's number three as coding has gotten a lot better. Developers are a lot have a better knowledge of injection attacks. So it's dropped down 2 steps, and then and for the top 20 for the 2021 version, the top 10, um, it injection encompasses all injection attacks. Where previous versions of the OWASP top 10, SQL injection was its own vulnerability, cross-site scripting was its own vulnerability. So now they kind of combined all of those into this one. Um, Insecure design, security misconfigurations, those are pretty much self-explanatory. Same thing with vulnerable and outdated components. Update your stuff. Identification and authentication failures also pretty self-explanatory. Software and data integrity failures, security and logging. So I mean, they're all pretty self-explanatory, but we'll go ahead and cover them in detail. Okay. So to access the machines, we're going to go ahead and click Start Machine and make sure that we do that, and then we're also going to we'll start our attack box when we get ready to. All right, so we're going to jump into, and like I said, there's 23 tasks, so it looks like we cover the top 10, but then there's some supporting materials like you'll see here for cryptographic. You'll see there's some practical. So there's 22 really. There's 22 tasks that we're going to cover today. Okay. So again, this isn't meant to be super formal. This isn't, you know, I do go in, we do explain, we do go in depth, but we also keep it light. We talk, we hold each other accountable for whatever projects we're working on. So again, if you're new here, feel free to hang out, whatever it is. I mean, you can use this as a co-working stream. A lot of folks will have this playing while they're working on whatever they're working on. However you want to do it, feel free to. Like I said, it's not like I might, not that I'm gonna quiz you, but it's not like I'm gonna, test you and grade you at the end. Now, if you were one of my students in my cybersecurity cohort, that would be different. But this is just a formal thing. And also, I'm human. So as we get through answering some of these questions, sometimes I struggle with answering the questions. I'm not paying attention. Thumbstick, no, test us. All right, I'm gonna quiz you. I'll pop some quiz questions in there, Thumbstick. But yeah, like I said, sometimes I struggle answering the questions, even though I have enough. Whatever, it happens. So anyway, like I said, Ty, Wusa, Thumbstick, yes, I will quiz. And like I said, anybody else who is tuning in, like I said, feel free to say what's up in the comment section. Also, I think I mentioned this before, but as you see the bot, pass or fail. If you fail, you have to subscribe, follow to learn more. Hey, you know what? That's not bad though. That's not a bad idea. But as you see, the Nightbot is posting up links. Those are affiliate links to some things that we recommend. So like you'll see, we have NordVPN. When you click those links or you purchase anything while clicking those links, the proceeds do go back to supporting us. That goes into things like the equipment, like the RAM I just purchased for all the PCs, the cameras. Oh man, Thumbstick, when I get a chance, man, I'm gonna show you. So I ended up buying more of those cameras and more of the Wise cameras, and I do have them all set up like head cams. Right now I have 6 head cams, and then I have one that I haven't decided what I'm gonna do with just yet. I gotta get like 6 more so I can have all 12 on the wall. And then, I'm sorry, so I have 6 on the wall for head cams for the esports stuff, and then I have one over in the corner with the consoles when we do our tournaments. And then I'm gonna get a couple more to do like head to head for when we do our Friday Fight Night series. Yeah, man. Like I said, I've been, yeah. So we do have we have a couple of links for NordVPN, WebRoot antivirus, Zenny Optical. So Yeah, man. Like so we started we've been using some of the Fortnite streams to test it out, and like I said, I'm really liking how it looks. Um, Honestly, I gotta sit down and move everything over into uh, vMix so we can get like a production thing going. Like I said that's something else, man. Like I said, I don't know. Right now, I just need to get oh yeah, I just need to get these things updated. So right now, like I said, so if you see those proceeds do go back to help in the center. Right now, the goal is to uh, generate enough revenue so that we can upgrade our graphics cards here, um, and also uh, get more marketing, more advertising. So we'll be talking about that very soon. I hate to put it out there but hey, sometimes you got to do what you got to do. All right, so broken access control. So when talking about broken access control, um, you have you have websites like you have websites that are just public websites that just allow you to access whatever like if it's a blog site or something like that, or then you have websites that have some type of access control or authentication, right? So that could be your social media, that can be your bank account, that could be even if you're a content creator, you might have some stuff behind a paywall, so you might have like a Patreon or something like that. So these are things that will require some type of administrative access to get to the other side. So if websites can access, if regular users can access those protected, whether they're paywalls or protected stuff, then that's an issue with the access control. Okay. Um, if a regular user is able to access things that are supposed to be secure and protected, then you run the risk of those users or malicious attackers gaining access to sensitive information or being able to um, uh, have unauthorized access to make certain changes to face the website or what have you. Okay, so broken access control basically is a way that users bypass your authentication and authorization, right? So if you're a regular user and you find a broken access control vulnerability, you might have access as a power user or as an admin because now you're able to access things that you weren't supposed to. Okay, they said so. They gave an example about a vulnerability that was found in 2009, where an attacker could get any training could have been better at the beginning, still have holes in understanding at work. Oh, Ty, you're talking about the conversation between you and your manager. You want me to? You want to hear my thoughts on job training? Because I can go on my soapbox from time to time, and yeah. But anyway, in this situation, the researcher found that they were able to access several frames to reconstruct a video. So actually, I don't think I've heard of this one before. Let's go here. So they were able to steal private YouTube videos from one frame at a time. No, I don't think I've ever saw this one before. Interesting. Alpha rate impending. Oh, there's a PLC. Okay, hold on. It's not that long. So let's see if we can catch it. All right, so we're gonna watch this, and then yes, I'll give you my thoughts on that. All right, so okay, so it looks like they're basically in they're in a user's private video. Okay, there was a Python script that they pushed. Looks like they're doing a brute force of some sorts. This is why reading is fundamental. We should have read it first. Yeah, we should have read it first. All right, hold on. I wanted to make a proof of concept. Okay, I quickly Googled base 64, pasted the. Okay, so that was so he was pulling the frames of the private video. Every time I marked a moment, a post request was made to get thumbnails. Okay, so he was able to access the private videos of other users, and then whenever he made a request, it basically created a thumbnail. So he went through the entire video second for second and basically thumbnailed everything. Hey, look, we're in the more video section. Yay. Okay. That's interesting. Okay, so here's my rant about training. Especially in what I've seen in recent history, or when I've talked to some mentees, right? They companies seem like they expect you to be able to know the ins and outs of um of their job just because you have experience, right? So, for example, you work for an Appsec shop, or you take an Appsec job because you have Appsec experience, right? So you've worked in an Appsec shop before, you've worked for other companies before, and now you get hired by a new company, and they're like, oh, well, since you have all this experience, you should just be able to come in on day one and tell us what's wrong with our stuff, right? There's no training on their specific applications. There's no training outside of like an introductory call to understand the teams, the politics of it, right? Um, and like I said, the specific training of whatever, right? Like, no, I shouldn't say no two apps are the same. But if you worked on a fintech app, so if you worked on a financial type app, right, and now you work for a school, right, that setup, that application might be different than the other one. But they just kind of it's almost like they don't want to train you, right? And then also, there's different components. Like the whole reason why I'm even doing this AppSec thing now is because when I got into, I've told the story before, but um, how I learned API security was literally by accident. It was because the job that I applied to and got hired for hired me to be their web app pen tester. It was supposed to be a web app security architect slash pen tester, and then tasked with the goal of testing them for PCI compliance. And basically, what happened was the first time put my I got set up to do the pen test. Um, I didn't know what the hell I was looking at. I saw. I'm like, why is there a bunch of JSON here? What? Like, where's the HTML? Where, it was like, where's all the things that are common in web applications? And they were like, "Oh yeah, yeah, it's a little different, right?" And it wasn't that it was a little different; it was completely different because the web apps or the application was like completely API driven. but there was no there was no training on it. I had to essentially teach myself how to do it. And then when I realized, hey, this is different, I went to management, was like, hey, can we get some training? Can we do this? Can we do that? And it was like, okay, well, what we'll do is we'll set up a call with the developers and they can tell you how the app works. That's not training. That's not security training. That's the developers telling us what the purpose of the application was, or the application that they coded, or that feature that they coded, right? And now, in the grand scheme of things, that does help. That is something that is necessary, but but that's not the first thing I need to know. I need to know I need to know how to look at what I'm looking at first. I need to know how to navigate that first. I need to know how to test for those vulnerabilities. Then after that, now let's go back to the developers and say, hey, tell me about your application. Tell me about this feature, right? So now I can look at it with the knowledge of what to look for and test it, right? So when we do the practical stuff, and I'm like, hey, if I were testing this application, this is how I would look at it. That comes with training. These companies is like they use that term "hit the ground running," and that "hit the ground running" is just an effing cop out for them to say, either we don't want to really bring you up to speed, or we don't know ourselves, right? Like, how do you get brought into a company by someone who was a senior VP of security, who ended up becoming the CISO by the time I left, and did not know how the application that he is tasked with securing and hiring professionals for was built, right? Like, even well after I left, they would still call and ask me questions about some of the components, because I at that point I was the person who literally had all the knowledge from a security standpoint of how to test that application, and from sitting with the developers. So it's like, so the thing is like, I feel like they should, these shops say they're gonna, that they provide training. I think that's something that, some stuff that they should provide day one when you're doing your 30, 60, 90-day plan. Some sort of training, like not sexual harassment and anti-money laundering and all that other stuff. I'm talking about actual technical training. Like, they should send you to a course, or make you take an online course, technical course, of what is expected. Even though you have the experience, there should be some type of training involved. All right, so the rant wasn't that long. All right, so anyway, so let's get back to it. Yeah, I think it's crap that these companies will literally throw you into the deep water and tell you to swim, and then when you're like, okay, cool, I have no problem doing that, but can you at least tell me what to look for? I mean, like I said, and with the turnaround, you have these companies where they don't even know, because they're still fairly new. This is why stuff like especially in Appsec shops, this is why documentation is vital. Like the Appsec contract I'm working on now, I'm literally I walked in there day one and was like, yo, where's your documentation? Where's your documentation? Where's your application diagrams? Where's your previous pen test? Let me see. Let me get all those reports. Where's your WAF setup? Where's your WAF rules, right? And these are things that I probably won't even touch, but I'm asking for all that documentation. So one, I could look at it myself, and two, I will then create my own section in wherever their documentation is held, whether it be Microsoft SharePoint, whether it's Confluence, wherever it is. Um, I do my document. I have that documentation, and now it's all there. Um, so now the next person who comes into the security shop, is, hey, where's all this stuff here, right? Because usually most shops that I walk into, they either don't have any documentation or the documentation is spread out all over the place. So like my first 2-3 weeks, like I tell them, like, don't expect me to do anything hands-on technical for at least the first month, because I'm going through all your documentation, and if you don't have the documentation, I'm going to take what you have and I'm going to start creating it. And they look at it like, oh my gosh, he's such a great team player. Yes, I'm being a team player, but I'm being honest, it's a lot for me, because I follow, like I follow that documentation, right? I that I so the Fed documentation didn't connect the dots. So this is so Ty. Now I know it's a little extra work. So this is what I would do. So this is where what I would have done is I would have. So let's say there's a gap between this document and this document. When I start doing the technical stuff, I'm trying to put those pieces together, and I'm making that documentation. Whether I upload it onto the team share or whatever, or whether I have my own, whether I keep it for myself, I have that documentation, because now when it comes back to it, if I have to review it, and let's say it's 6 months from now, and I have to review it, and then I see that I'm looking for that documentation again. I'm like, wait, there's something missing right here in the middle. I'm bridging those two gaps together. See what I'm saying? So, like I said, it's a little extra step, but and I'm not saying that this is what you do. I'm just saying for me, for my own sanity, I'm bridging those two pieces together, and then like I said, I'm either keeping it for myself or I'm usually sharing it with everybody. Now, I ain't gonna lie, if I start noticing that if I start noticing that the culture at the job is getting toxic, or that they start looking at it like this is what is expected, then I start kind of nipping that in the bud, because it's like, nah, I was doing this honestly for me. And if y'all start taking advantage of that, then that's an issue. All right. So we understand what broken access control is. So now a perfect example of broken access control is insecure direct object references, or IDORs. This is also known as broken object level authorization, and is actually number one on the OWASP API top 10. So it says that IDORs refer to an access control vulnerability where you can access resources you wouldn't ordinarily be able to see. This occurs when a programmer exposes a direct object reference, which is just an identifier that refers to specific objects within the server. By object, we mean a file, user, bank account, and a banking application, or anything really. So what I love about IDORs, or broken access control, or BOLAs, broken object level authorizations, is that it does not require like super elite hacker skills to accomplish. It honestly requires the curiosity of a 5-year-old. And what do I mean by that? So look at this example. You see is HTTPS bank.thm account ID, and then you see 1.1.1, or you see 11111, right? Now remember what I was telling y'all the other day. Remember when I said, oh, if you see a user account 1, what happens if you go 2, 3, 4, 5? Or if you see if it says user, what happens if you switch to admin? That's what I'm referring to, right? I was referring to IDORs, or insecure direct object references, or broken object level authorization, right? It doesn't take a genius hacker to go, if the ID equals 6 1s, what happens if I put 6 2s? Or you don't even have to go to 6 2s yet. What happens if I do 1 1 1 1 1 2, 1 1 1 1 1 3? You know what I'm saying? What if I do that? Right? So now, or you can just again follow that convention. If it's all ones, then the next one's all twos, and so on and so forth. Right? And believe it or not, there are a ton of vulnerabilities that are out there just like that. there was a big one back in the day where the user's ID for a cell phone company, the user's ID was their cell phone number. So now, if you knew if you knew the cell phone number, if you knew the person's cell phone number, then you could access their account or you could access their stuff, right? But what happened if you just started guessing phone numbers, right? So now technically that vulnerability would give that attacker access to every single user that had an account with that cell phone provider. Hold on one second, y'all. Oh my. Okay. Sorry about that, y'all. Dad stuff. All right. So anyway, um, iDoors. So like I said, there was a vulnerability not too long ago where again technically that person could have created a script that would have randomized that could have done like random phone numbers, and he could have kept that script going until he got every single account on that cell phone provider. And like I said, it doesn't require any tools. Well, in that situation, you could run a script, but to find the vulnerability and provide proof of concept, you do not there's nothing you need to do for it, right? There's no I don't you don't need Burp Suite to do that. At least when it's as simple as just like six like 11111, right? Now, whether it's encoded or it has some randomness to it, that's where you can utilize some of the tools. But for the most part, it's literally this simple, and you're going to see this a lot. You're going to see this a lot when you start looking at vulnerabilities. So again, it makes sense that this is number one because for one, it's probably the most devastating and it's the easiest to exploit. Right. So let's just go here real quick. All right, so we're going to 10. Come on. 10.10.109.248. And now it says the user is Newt and test 1, 2, 3, 4. Okay, we're not going to save that. So now if you look, things to buy from the store: carrots, potato, cheese, lots of chocolate, right? Now if you look up here, it says no PHP, no ID1, right? So now if we change that to 2, now we have another, now we've accessed another node, right? Let's, how about we do 10? There's nothing found there, right? So we know that it's less than 10. Oof, if the server, it is slow again, right? So now we can do 1, we did 2, let's do 3. You're not supposed to see this node, which means you are on the right track, right? 4, okay, 5, 6, 7. Okay, so it looks like we're done, right? So there's 6, right? 9, right? So let's go back to 6. Okay, so there's not 6. Okay, so let's go back to 5. Okay. So now let's go back to 0. See? So here, there's our flag. All right, so let's put that in there. Submit. All right, so that's literally how easy that vulnerability is in some cases. I won't say in all cases, because sometimes the IDOR, it takes a while to find it, but in a lot of situations, it's literally that simple. And like I said, and they're like you can find them fairly easy. Actually, I think Nahamsec actually just put up a video the other day, or was it today? Let me see. Nahamsec found an IDOR vulnerability. So he found a broken access control vulnerability that got him $5,000. I said we're not gonna. All right, let me see something real quick. All right, so I'm just gonna put the link in because I don't want to. Okay. All right. So anyway, so we've covered that. All right. So now we're gonna move on to number 2, which is cryptographic failures. So cryptographic failures are basically a misconfiguration of any of the cryptographic algorithms or encryptions, right? So TryHackMe says refers to vulnerability arising from the misuse or lack of use of cryptographic algorithms for protecting sensitive information. Web apps require cryptography to provide confidentiality. For example, when you're accessing your email account on your browser, you want to be sure the communication between you and the server are encrypted. That way, an eavesdropper trying to capture your network packets won't be able to recover the content of your email addresses. So this is known when this is known as encrypting data in transit. So this is when you're sending data, right? So when the data is in transit. And then when it gets to its destination and it's sitting there, that's known as data at rest. So you need to. So typically, how encryption works is you want to make sure that the data is encrypted when it's being transmitted, and then you also want to make sure that the data is encrypted when it's sitting in its server or its database or wherever it's housed. Okay. Cryptographic failures often end up in web apps accidentally divulging data. So let's go into the supporting materials. So here it says the most common way to store a large amount of data in a format easy accessible is a database. Okay, so we talked about SQL, right? So as previously mentioned, a flat file database is stored on a file disk. I'm trying to see. Do we do it? Okay. Read and understand the supporting material. Okay, so all right, so actually jumped a little bit. So in a production environment, it's common to see databases set up in dedicated servers running a database service such as MySQL or Maria database. However, databases can also be stored as files. These are referred as a flat file database, as they are stored in a single file on the computer. This is much easier than setting up an entire database server and can potentially be seen in smaller web apps. Accessing the database server is out with the scope of today's task. So let's focus instead on flat file databases. As mentioned previously, flat file databases are stored on a file on the disk of the computer. Usually this wouldn't be a problem for the web app, but if it happens, the database is stored underneath the root directory, which is one of the files accessible to the user connecting to the website. Well, we can download and query it on our own machine. The most common and simplest form of a flat database is a SQLite database. These can be interacted with in most programming languages and do not have a dedicated client for querying them on the command line. That client is known as SQLite 3 and is installed on many Linux distributions. Okay, so here you're seeing how you can access it using the SQLite commands. Here you're getting the information on the tables. You see that there's a tables called customers. And now if you wanted to, you can dump all the information all the tables from that customer. You could dump all the information from that table. I did say that. Okay. So here you see the ID, customer name, credit card, password. So now they said select wildcard. Remember that wildcard is basically everything from customers. And now it dumped all that information. And now you see it says customer ID, 0, customer name, credit card information, and their password. Okay, so what should have happened is there should have been some type of encryption, so that when they went to access it, they weren't just able to pull that with a simple query. All right. Another example is, and I actually do this quite often. So let's say you get a password hash, right? So passwords are usually, or they're supposed to be, I should say, hashed. So a hash is essentially an algorithm that will create that will generate random characters for your password, and then you would check the hash to make sure that it hasn't been altered in any way, for that file. But with password hashes, if you're able to steal the password hashes, you'll be able to go to a website called CrackStation, and depending on what hash is being used, if it's using a weak hash like MD5 or something like that, CrackStation will be able to basically break that hash and give you that password fairly quickly. And this is exactly what it looks like. So you go to CrackStation, you type in, you would paste your hashes here, as many as you can find, and then you would just run crack hashes, and then it would give you, if it's capable of finding it, it will give it to you right here in green. It'll tell you the type of hash it was, and it'll actually tell you what the password is. Okay. All right. So it says now we're gonna go put is gonna we're going to put our stuff to the test. We're gonna go to the website and we're gonna go to port 81. All right, so now it says have a look around the web app. The developer has left themselves a note indicating their sensitive data in a specific uh, directory. Okay, so first let's just kind of walk around a little bit, see what's going on. Okay. Okay, so mail to sense and sensitivity.xyz, blah blah blah. You've reached a future world, all things therapeutic. Okay, that was set up your existing email. Oh, okay. That's because we did that contact. We don't actually need to do that. That's for Thunderbird. Okay, stop. Okay, so we're back here. So like I said, so we're looking. Where 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 else should we look? Right? So we there aren't any other links, right? There's just one link here for sense and sensitivity. Here's a login page. I mean, I could test for SQL injection, right? Valid credentials. Right? Okay, so there's nothing really there. I can go back here. Where should I look? Since you said quiz, based on what we've done before, where can we look? And remember, and they basically gave us a hint. So it says, have a look around the web app. The developer has left themselves a note indicating that there's sensitive data in a specific directory. What is the name of the mentioned directory? Well, now, all right, Thumbstick. Well, then that means now you're gonna have to find you're gonna have to find someone to. Oh, you're at the gym. No problem. I'll be nice. All right. So basically, we're gonna go ahead. We're gonna click more tools, and we're gonna check here. So we checked here. So there's the HTML. So there's nothing there for that. So we'll come back. Now how about we inspect the elements? Okay, so here you see there's an image source here. Okay, check the footer. Nothing there. Right? So right, okay, so let's see, we don't see anything here either. So we're gonna close this. Right, let's just double check again. We're going to do here. So again we're just double checking. All right, so we check again. So again, just double checking. So how about we check the source code of what else can we access? We can access a login page. So now let's check the source code there. All right, so this all looks here, and then must remember to do something better with the database and store it in assets. So here you see there's a developer comment that they left to themselves, but the website is public. So that tells us that there's something called assets. So now let's go ahead and let's see what happens when we go to assets. So now when we go to assets, you see there's a parent directory, there's CSS. All right, we can go back to the parent directory. Oops, come back. All right, we can go to JavaScript, console scripts. So let's go ahead and answer that question first. It was slash assets. Okay, and then it says navigate to the directory you found in question one. What file stands out as being likely to contain sensitive data? So let's see. There's a lot going on in that document. So let's go back to the parent directory. Now, how about web app DB? And that actually downloads a file. So webapp.db. Now it says the next one is user supporting material to access the sensitive data. What is the password hash of the admin user? So we went ahead and so remember we clicked that web app DB and it actually downloaded the file. So if we wanted to read that file, or if we want to remember, we could use a SQLite command. So we'll go ahead and bring up a prompt. Let's go ahead and change our directory to downloads. Just a double check. What? What's this open here? Where'd you go? Oh, because you went to the root. All right, let's just move you to desktop then. It went, for some reason, all right, it downloaded to the root folder. All right, so now let's go to the desktop. Let's clear this because I hate that. And now we have our web app DB. So now if we type in SQLite 3 web app DB, now you'll see that it's saying enter help for hints. So we'll just hit help. I'm sorry, I shouldn't do. I meant to do .help. Help. Oh my gosh! Learn how to spell that. Okay. Let's try this again. All right, so we're gonna go. Like I said, we're gonna type in SQLite 3 web app DB. And then what we're going to do is we're going to type in, we want to see the tables, not T-Bales, tables. And now you see we have sessions and users. And then if we wanted to get the information for the users, we'll go pragma, table _ info, users, semicolon. Now you'll see we have user ID, with the text, username, text, password, text, admin, integer. All right, so now let's go ahead and what did it say up here? No, that was part one. To dump, well, what is it? To dump everything. Yep, it was select wildcard from users semicolon, and now there are our hashes. So let's go ahead and we're gonna copy our hashes. Let's go here and we're gonna go to crack station. I'm gonna go crackstation.net. And now we're going to enter our hashes. So we have that one there. We have, come on, Bob. We're going to copy Bob's, paste Bob. And then we're going to copy Alice. And we're going to paste Alice. And then make sure, let's move this over so y'all can see it. All right. We're going to tell we are not a robot. And we are going to do that by verifying that we can click everything for motorcycles. And now we have to do bicycles. Okay. All right. So now we have our 3 hashes that we just got from the database, and we're going to go ahead and crack them. And as you can see, we got 2 passwords back. So we got the first password, which was admin, and then the second hash was for the user Bob. And as you can see, the passwords are right here. So again, it was an MD5 hash. So Alice has the only one that's probably a secure password out of the 3 of them that's not being hashed by MD5. Okay. All right. So now it says, what is the password? Oh, it wants to know the password hash for the admin user. We'll go ahead and paste that. And then the admin's plain text password is here. And now if we go up now that we have the admin's credentials, we can actually log in as that user. Right? So we click here and then we just type in admin and type in our credentials. We don't need to save it. And now we have our next flag. All right. And that is cryptographic failures. So again, just to kind of give a quick breakdown of what we just did, we found hard coded. Well, they weren't even credentials, but we found notes. We found information disclosure vulnerability, right? Which honestly could be, no, it's not hard coded credentials, but it shouldn't be there. We found the comment we found the developer's comment in the source code, which allowed us to find that hidden assets folder, which then gave us that web app DB file, which we then use SQLite to access. We dumped the table. We got the table information, and then we dumped all the user information. And then from there, we were able to crack the hashes of 2 of the passwords, and then log in as the admin level user. again, and this is a typical process, right? What's going on, Lou? This is a typical, like, this. Yes, it's a flag or it's a CTF environment, but this would be the methodology that you would use, right? So, like, if this, like, for example, you're testing a web application, you do a source code review, you get the developer code or the developer comments. There might be a note in there like that, or there might be hard coded credentials or API keys. Then you use those credentials or those API keys to access that information, or you're to a database, and then from the database you dump the database, and then from that database that you just dumped, you gather more information that you can use later. That's how real world attacks happen. That's how real world pen testing is done. That's how real world cyber attacks and data breaches are done. They find some type of access control vulnerability, or they find some type of weakness, and then they're able to exploit that and lead into another that leads into something else, right? So in this situation, we found we found the we found the developer code, which led us to that directory, which led us to the file, which led us to the hashes, which led us to the cracked hashes, which then led us to the usernames and the passwords, which allowed us to log in the application. Right? It's literally that process. Any of those vulnerabilities on their own would, I mean, there's a couple that will probably be deemed high, but a lot of those would probably be deemed medium or whatever. But now that you're able to chain all of that together, that's immediate. That's a critical off top. If that were a bug bounty, that would be a big bounty. Have you used DB browser for SQLite? No. All right. So injection. When dealing with injection, they're still very common, even though they're no longer number one. They are still common. The application, like I said, so what happens with injection vulnerabilities is if the application doesn't have the proper security features or like input sanitization or anything like that, it interprets your user control input as actual commands or parameters, right? So remember when we were messing with it last night, trying to do the cross-site scripting, when we were putting in those script tags, that had some type of protection in there that was blocking that. But a lot of applications don't allow it, or a lot of applications may only filter some of the basic stuff. Like there are some queries or some commands that you can put in there that can trick it. You can do what we did, where we passed it through Burp Suite and encoded it. There's so many different things you can do. So it's important for developers to use um, the proper libraries that will validate and sanitize everything. Okay, so the type of injection vulnerabilities, you have SQL injection. So that's when, oh, I'm sorry, I thought they swung the door open and hit my car. We're about to have a problem. Um, so that's when they're using SQL queries and they're passing it through the input sections of the application. And if it's not properly sanitized, then the attacker can pass those SQL queries to manipulate the data on the back end. Okay, that would actually allow them to access or modify um, the database information from the app from the application. So there are, like I said, so if it's not properly sanitized, like I said, you can essentially do everything that we just did in that, like when we did in that SQLite in the command prompt. You can essentially do the same thing using if there was a SQL injection vulnerability in certain parts of the application, right? You can actually dump the database and have it like dump into a certain part of the application. Then you also have command injection. This is when you're able to actually talk to the backend server, right? So and pass commands to the backend server. So this would be like, let's say it's a Linux. The application is has a Linux server on the back end. Command injection is I'm actually able to send Linux commands through the input of the web application, and it communicates with the Linux server and gives me back the information. So, for example, if I wanted to access the password file, if I had access to it, and there was a command injection vulnerability in the application, I could put that command in the I could put that command in the application, and the application would then talk to the server, and the server would then present that information back to the application. Okay. It says the main defense for preventing injection attacks is making sure that user-controlled input is not interpreted. So again, that's where we talk about sanitizing input. So you can add an allow list, or an allow and deny list. So this is when input sent to the server, the input is compared to a list of safe inputs and characters. So you should basically have a list of commands, scripts, uh, prompts, special characters that aren't allowed when in the input boxes. Similar to the application we looked at last night, where the script tags, it wouldn't let us do the brackets for the script tags, right? Or it does allow it, but what it does is essentially it strips it of its power, right? So it'll just look at it like, okay, this is what it is, but it's not actually communicating with the back end server to execute those commands, right? And then or when it gets stripped, like you could type it in, but then when it's being processed and going, that data is being transmitted to the server, all of that gets stripped before it gets to the server. All right, so looks like we're going to do some command injection. Are we actually going to do it? Yes. All right, so with command injection, all right, so this looks like it's a PHP application. So again, it says command injection occurs when server-side code like PHP in a web application makes a call to a function that interacts with the server's console directly. An injection web vulnerability allows an attacker to take advantage of that call to execute operating system commands arbitrarily on that server. The possibilities for the attacker here are endless. They can list files, read their contents, run some basic commands, and do some recon on the server, or whatever they wanted, just as they were sitting in front of the server and issuing commands directly into the command line. Once the attacker has a foothold on the web server, they can start the usual enumeration of systems and look for ways to pivot around. So here's the code example of the PHP code. So it says, let's consider a scenario. MooCorp has started developing a web-based application for cow ASCII art with customizable text. While searching for ways to implement their app, they've come across the cowsay command in Linux, which does just that. Instead of coding a whole web application and the logic required to make the cows talk in ASCII, they decided to write some simple code that calls the cowsay command from the operating system console and send it back. And just for the record, is it on here? I was gonna say, okay. I was gonna say, for the record, cowsay is a legitimate thing. You can't do it here because it's not installed, and I'm not going to install it on their machine. Okay, so here's the code that they use. So again, this is just PHP code. So it says, see if you can determine why their implementation is vulnerable to command injection. Oh wait, I'm sitting there. Look, I'm looking like y'all are actually reading the code. I forgot some of y'all are just on audio. So basically, what is happening is checking the parameter to see for mooing. Okay, if the variable mooing, if it is a variable mooing, gets what was passed into the input field. Checking the parameter, checking if the parameter cow is set, which is right here. So cow equals default. So if it is, the variable cow gets what's passed through that command parameter. The program executes a function pass through Perl user bin cow say -f cow moon. The pass through simply executes a command in the operating system's console and sends the output back. You can see that our command is formed by concatenating the cow and mooing variables at the end of it. Since we can manipulate the variables, we can try injecting additional variables and commands to trick it. So again, this pass through is the issue. Okay. So now that we know how the application works behind the curtains, we'll take advantage of a bash feature called inline commands to abuse the calsay server and execute any arbitrary commands that we want. Bash allows you to run commands within commands. This is useful for many reasons, but in our case, it will be used to inject the command within the calsay server to get executed. Okay, to execute inline commands, you need to enclose them using the $ and then your command here. If the console detects an inline command, it will execute it first, then use the results as the parameter. So if you look here, there's echo, then it says my username is, and then you see the who am I in that inline command. Okay, then it reads out my name is J Doe. So execute who am I, then you'll type in that, and then it'll parse the result back. Okay, so now in the calsay server, you choose your default, you choose your cow, then you do that who am I. So now that you have that cow, and then you have that mooing variable. Remember the cow and mooing variable up here? And now what's going to happen is you're typing in the F default, but then it's mooing that who am I? All right. So now when the cow, so when it comes back, it'll actually give you the answer of who am I. Okay. All right. So let's go ahead and give it a shot here. We'll go back and we'll go to 82. So now we have our calsay online. And now we're going to go ahead and give it a try. So we have our inline commands, and then we're going to go with ID, and we'll hit submit. And then as you can see, we got our UID Apache. So it's giving us that information, right? So let's try it. Let's try another one. All right, so now we typed in, here's another one. We typed in ls-a. So we have a Dr. Pepper. It looks like drpepper.txt. All right, now, just because I want to see, let's see what happens if we do that. So you see, we can we even can read files, right? So I just did the cat. So it says, I'm sorry, Mario, but the Dr. Pepper you were looking for is in another web app. All right, here, let's try another one. Right, so now we can see what directory we're in. Okay, how about new name -a? All right, let's do this. Let's do who am I? Yikes. Come on, learn how to spell, Davin. Okay, so we're the user Apache. Then it says, how many non-root, non-service, non-daemon users are there? Okay, so these are the programs running. There are, what does that look like? That's a group ID. Groups. Ouch. Ouch. No, sorry, I was reading them. Let me see here. I was reading that message real quick. Are y'all coming in? One second, y'all. Just looking to see if they're standing in there like they're about to come in. All right. Anyway. Okay. All right. So let's see how many users there are. So remember, I was saying before we could. Oh, duh. I didn't actually give it a command. Cat Etsy password. All right. So how many? The question says how many non-root, non-service, non-daemon? How many non-root users? Non-root, non-service, non-daemon. Apache's a service. Doesn't look like any. Yep. No users. All right. What's the next one? What is the user shell set as? Isn't that? And okay, I'm not gonna. All right. Okay. So the shell, anyway. So the user shell is what's that? Var sbin no login. So you can. So it'll tell you. So basically, it gives you the user information, their ID, and then this is the shell that they're using. So if we go ahead and sbin / no login, and then what version of Alpine Apache are we running? That was with. Did we do that before? Let me see. I think it was. Okay, no, I don't like. Is it 5.4.0? No. not. No, it's not. It's not. It's not. So then we need to do. Sorry. We need to do $cat. Etsy OS release 3.16.0. 3.16.0. All right. How are we on time? Yeah, Ty. Yeah, I'm using their attack box. What I'm thinking is when we get back to the hands-on stuff, I'll probably download BWAP and we'll go through the top 10 vulnerabilities there. Although BWAP, I think, covers the 2017 top 10 vulnerabilities. So I don't think there's going to be any IDORs in there. I'll think about it. So anyway, all right. So insecure design. So insecure design is number 4. And it refers to vulnerabilities which are inherent to the application's architecture. So it says they are not vulnerabilities regarding bad implementations or configurations, but the idea behind the whole application or part of it is flawed from the start. Most of the time, these vulnerabilities occur when improper threat modeling is made during the planning phase of the application and propagate all the way to your final app. So that basically means from when they're whiteboarding the concept of the application, no one said, hey, we should probably check for this, or what if this happens? And because of that, it got through the whole design process. It went through as many phases of the many environments that they have. So they might have like a dev environment, they might have a staging environment, and then they might have a production environment, right? I've seen some Appsec shops that have usually 3 or 4 environments. So they'll have, like I said, they'll usually have a dev environment, and that's when it's being developed or whatever. Then they'll have a staging, which is supposed to be it's supposed to mimic production without actually being production. Like, so production and staging should mirror each other. And then what that allows you to do is it allows you to test in staging and then implement those changes to production. So you don't necessarily have to test in prod if you don't need to. Right? So it says most of these propagate all you want. Some other times, insecure design vulnerabilities may also be introduced by developers while adding some shortcuts around the code to make their testing easier. For example, disabling OTP validation in the development phases to quickly test the rest of the app without manually inputting the code at each login, but forget to re-enable it when sending the application to production. So again, that's another insecure design vulnerability. Like we said, like that note that we saw in the source code, that would also be considered insecure design because that shouldn't be in the final version of the application. Okay. So it says a good example of such vulnerabilities occurred in Instagram a while ago. Instagram allowed users to reset their forgotten. I remember this. So they allowed them to reset their password by sending a 6-digit code to their text message. If an attacker wanted to access the victim's account, he could brute force a 6-digit code because there weren't any protections there. As expected, this was not directly possible as Instagram had rate limiting implemented after 250 attempts. So what the attacker did was they created a workaround by using different cloud servers. And what would happen is every so often that server would get a new IP address. So Instagram was doing, you had 250 attempts per IP address. So what the attacker did was he scripted a code. He scripted a program that would get to about 247, 248, 249 swap IP addresses. And then as you started out with IP addresses, your attempts got started all over again from zero, right? So that's like I have 249 attempts to crack in to break into your account, and after 250, it'll raise an alarm, it'll set off alerts, it'll lock everything down. Okay, so if I know I have 250 attempts per IP address, like I said, I would get as very close to 250 as I could, swap IP addresses. Now I have another 250. Okay, and this is exactly what happened with Instagram. Okay, so by for so now and so blah, 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 blah. It was found that the rate limiting only applied to the code attempts made from the same IP. If an attacker had several different IP addresses from where to send requests, he could now try 250 codes per IP. For a 6-digit code, you would have a million possible codes. So an attacker would need 1 million divided by 250, which would be 4,000 IPs to cover all possible codes. Okay, so like I said, so all he did was like literally all he did was run a script that would brute force get as close to 250 as possible, switch IP addresses. All right, so now it's telling us to do a real world practical example. All right, so try to reset Joseph's password. Keep in mind the method used by the site to validate you are indeed Joseph. So username is Joseph. That's not how you spell Joseph at all. Username is Joseph, and then the password we're gonna say sub. Okay, try to reset Joseph. All right, so the application has a design flaw in its password reset mechanism. Can you figure out what the weakness is to access it? All right, so what are we looking at here? So let's go to here, go to I forgot my password. So the username is Joseph. Continue. Not now. What is your mother's sister's son's nephew's neighbor's friend's name? Sure. What's your favorite color? Okay, so we'll do that. So now, because I don't know how to answer that question. What's your mother's sister's son's nephew's neighbor's friend's name? We don't know that answer. And then what's your first pet's current address? We don't know that one. So now what's your favorite color? That's simple. Simple enough, right? So let's try to go with red. Okay, incorrect. Try again. Blue. Okay, so that was wrong. Green. Success. Password's been reset. So you see there weren't any rate limiting or any protections there, and we just basically kept going until we accessed the password, right? Or got the right answer. Now, again, if we wanted to speed up that process, we could create a password list of a bunch of different colors and run that through Burp Suite, right? And that would have got it done faster. Okay, so it says Note, remember to move private files out of the server. But then if we go to private files, there's our flag. So we'll just copy that flag, and then let's look at the cat images. Monorail cat, and they told me I could be anything, so I became a cannonball. Okay, ha 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 ha, cat stuff. All right. So now we have answered the next question. So now we are at the halfway point. We are at number 5, security misconfigurations. So security misconfigurations, it says they're distinct from the other vulnerabilities because they occur when security could have been appropriately configured but was not. So again, this is clear. This is just any vulnerability. Honestly, can be considered a security misconfiguration when you think about it. But because again, you could have created stronger password policies. You could have validated. You could sanitize your input. You could make sure you're using proper encryption. You can make sure you're using proper headers. You know what I'm saying? So these are different things that you can do. But security misconfigurations can include poorly configured permissions on cloud services like S3 buckets. So again, that's also broken access control, right? Having unnecessary features enabled like services, pages, accounts, or privileges. Default accounts with unchanged passwords. Error messages that are overly detailed and allow attackers to find out more about the system. So that's also known as verbose error messaging, right? Not using HTTP security headers. So this vulnerability can often lead to more vulnerabilities, such as default credentials giving you access to sensitive data, XML external entities like or XXE attacks, or command injection on admin pages. Okay. For more info, look at the OWASP top 10 entry for security misconfiguration. So this is just a link to the OWASP page. I'll put it in the chat if you're interested. Okay, so debugging interfaces. So the common security misconfiguration concerns the exposure of debugging features in production software. Debugging features are often available in programming frameworks to allow developers to access advanced functionality that is useful for debugging an application while it's being developed. Attackers could also abuse some of those debugging functionalities if somehow the developer forgot to disable them. One example was when Patreon got hacked in 2015. 5 days before Patreon was hacked, a security researcher reported to Patreon that they had found an open debug interface on a WorkZug console. WorkZug is a vital component in Python-based web applications and provides an interface for web servers to execute Python code. It includes a debug console that can be accessed via a URL on the slash console. It will also be presented to the user if an exception was raised by the application. In both cases, the console provided a Python console that will run any code. So here's basically what it would look like. Okay. So this VM showcased security misconfiguration as a part of the OWASP top 10. So we're going to go ahead and access that application on 86. And now you'll see we have a to do title, read book, buy t-shirt, go to school, watch TV. Okay. So now let's go ahead and go to console. And now as you can see, we have that interactive Python console. So if we do ls-l, you see it doesn't let us do that just like that because again, this isn't just Linux. So what we have to do is we have to type in the Python equivalent of that. So we're going to say import operating system, and then we're going to say print OWASP open roll up Evan. and then we're going to type the command in the parentheses and quotations. We're going to close that, and then we're going to say .read, and then we're going to close everything up and make sure that looks right. So we have one, close. Okay, so now we should hit enter, and now as you can see there it goes. It allows us to list everything that is in this directory. So it says, what is the database file name with the DB extension? That is todo.db. How are we on time? We're at about 7 o'clock, so we're almost 2 hours in. Okay, modify the code to read the contents of app.py. Okay, so we're just going to go ahead and copy this. Here, and paste that over here, and now if we want to read, so we're gonna do cat app.py, learn how to spell, clear, stop. Okay, so we did that, and now it says, what is the flag? What is the value of the secret flag in the source code? So it's actually right here, but I was actually going to try to do something else, but that's fine. We'll just do that and do that. Okay. So we got our flag there. So vulnerability number 6, vulnerable and outdated components. So again, this is pretty cut and dry. This is basically the vulnerability when you don't update your stuff, right? So if you have components or especially when you're a developer, if you're not making sure your dependencies and stuff is updated, any extra components that you have is not updated, then they're prone to vulnerabilities, just like your operating system is prone to vulnerabilities if you don't install your patches. Best viewers on streamboo.com. Remove the space. Again, with the bots. Anyway, but yeah, vulnerable and outdated components are just that. When you have components that haven't been updated, and now because of that, they are open to the vulnerabilities that that would have been fixed had you patched your stuff. All right. So it says here, occasionally you might find a company, entity, or pen testing is using a program with well-known vulnerability. For example, company hasn't updated their version of WordPress in a few years and is using a tool like WPS Scan. You find is using version 4.6. Some quick research will reveal 4.6 is vulnerable to an unauthenticated remote code execution exploit. Even better, you can find the exploit already made on exploit database or exploit DB. As you can see, this would be quite devastating as it requires little work. So, and that's exactly how we would do it. We would look at the components, we would look at the services that are being ran, and then we're quickly Googling any vulnerability based on that version. And then from there, if once we determine that there is a vulnerability, we're looking to see if there's any vulnerabilities in the wild, which means, are there vulnerabilities that are publicly available? We're going to review those exploits and make sure that it's doing what it says it's supposed to do. And then we're just going to use that we're going to use that exploit to exploit your system. Okay, so exploit DB, search exploit, metasploit, We're searching, other websites. We're looking to see if they exist. All right. Okay. So recall that since this is known about known vulnerabilities, most of the work has already been done. Our main job is to find out the information of the software and research it until we can find the exploit. Let's go through with that example web application. Okay, so Nostromo 196, that's what I'm looking for that. What do you know? The servers already has a default page on the web server. You can use exploit DB to find it, right? So you see the Nostromo 196, there's a remote code execution. That's game over. There's also a directory traversal command that's in Metasploit. Again, now that's information we can use. 193, well, it's 196, so we know that doesn't apply to us. However, 196 does, and then this one beneath it might. We have to do a little bit of digging to see when it worked, when it worked, and when it was patched. Okay, so now if you find the vulnerability, you find the exploit, then you can actually run the script there, and it gives you that information. All right, so like I said, you kind of check the code, make sure that it works how it's supposed to work, or it does what it says it does. So again, you want to make sure that you're not accidentally opening up like ports or something on and that you're following whatever instructions. So sometimes it might tell you run like this command and then the URL or the IP excuse me, or the IP address of the target. So that's how you're checking that. Okay. All right. So now it says we're going to navigate to a new website on port 84. So now this looks like it's a bookstore, and it says all the information you need to exploit it can be found online. All right. So the site has been made with PHP and MySQL, procedure functions, the base layout. Use Bootstrap to make it more responsive. Responsive is just a simple web. All right, so we have Project Worlds. We have an admin login. So let's just go ahead and look around, do some digging. So again, if I had Burp Suite, I would, like I said, I would be clicking all of these just to make sure. Hey, I know Scott Hanselman, cool guy. I actually did his podcast last year. Project Worlds, let's go there. Okay, there's nothing there. Admin login 2017. CSE bookstore publisher book my cart. I'd love to hear from you. So again, we're kind of just digging around to see what we can find. Ouch. All right, so again, we're looking to CSE bookstore. So if we wanted to do that, I talked about SearchBoy before. Let me see. Can I access the SearchBoy on here? SearchBoy is on here. So if we do CSE bookstore, is there? Indeed, there is. So there's CSE bookstore 1.0. There's an authentication bypass. And then there is, all right, so we know that those exist. And the exploit is actually in here, right? But let's do what they're telling us to do. So we'll close this. We'll go here, and then we'll go to exploit DB. Stop. Reject. Go to exploit DB. And then so this is what exploit DB looks like. And then again, we'll just type in CSE bookstore. And now remember, we saw the same thing in there. But there's authentication bypass, there's persistent cross-site scripting, and then there's multiple SQL injections. Now we could test for all of these, but I'm just gonna go ahead and use the authentication bypass. Let's see if we go ahead and look at it here. See how the script works. So the payload is admin pass. So it looks like it's also doing um, it looks like it's also doing SQL injection. So we honestly don't even need to. It's not even a. It's not even a real exploit per se, or it's not a script, right? So let's just do. We'll make it easy on ourselves. We'll go to admin login. Okay. Users admin, and then the password is this SQL here. And then we'll hit enter. Not now. And as you can see, we are logged in. So again, we looked at CSE bookstore. We looked around before we jumped to conclusions. We walked around the app. We walked around the application for a little bit to check everything, and didn't see anything else that was too telling as far as what we needed. So we just went ahead and logged in from there. Okay, so now it says, what is the content of the opflag.txt? Which is interesting because which vulnerability? Hmm. So those are SQL, that's SQL injection. All right, so let's see. Boolean based blind. Hold on. Let me see where that is. So, in order for us to do that, we're gonna have to exploit it from. We're gonna have to exploit it from. We're gonna have to exploit it from the terminal. So let's go back here. Okay, let's try that again. Search, exploit, CSE bookstore, and then which ones are they? Uh, all right, let's go ahead and download the files. 460. Okay. All right. So it's not that one. Okay, so we know that, okay, so that's cross-site scripting. I don't think we need that one. Okay, so Boolean-based blinds. Okay, so that's web application vulnerable SQL injection in cart.php file by setting the SQL injection payload parameter. Dumping database credentials. Interesting. Trying to figure out which one. Trying to figure out which one. Oh crap! Add one more hour. Which one is that? All right, fine. You're not going to tell me there. Then there's got to be CSE Bookstore 1.0. Okay, so did I not put? Because I didn't put 1.0. Because this isn't there. Yeah, look, that didn't even. Did I? Is it because I didn't do here? What if I do one dot? What if I type in? And maybe that's my fault. SQL injection, authentication bypass. All right, so it's not me. CSE Bookstore 1.0. So if I Google it, interesting. That says online bookstore 1.0, but that's CSE Bookstore 1.0. But when I Googled it, it gave me this. All right, so let's read it. Online Bookstore 1.0. Okay. Oh, Tiberius made it. Shout out to Tiberius. Web shell upload. All right, well, I'm going to go ahead and I'm going to go ahead and download it. All right, let's go here. Go here, we'll open up our folder. Move that to our desktop. Close that. Minimize. We'll close. We'll CD into our desktop. And now let's go ahead, ls. There's our Python script. So now if we do Python, come on, Python 3, and then 4.7, right? And now it should give us a yep. So now Python, and then tells us to point the URL at it. So pointed at the URL, I should say. I'm saying it backwards. So we come back and our IP address is 10.10.109.248, and we're listening on port 84. We'll go ahead and hit enter. That didn't work. Why didn't that work? Oh, that's why. Because we didn't do HTTP. We'll hit yes. And now we have our RCE. So if we hit ls, now here's our information there. So now it says, what is the contents in the op folder? So we'll just go cat opt flag.txt. And then here we go. So it took us a little roundabout way to get it, because we typed in the right information, but it didn't give us the answer, right? It gave us some other exploits which we were able to use and access, but we needed to access information from the back end, from the server side. So now it required us to go back and find the right exploit. So we saw none of those other exploits work because those were text files. That was just kind of instructions on SQL injection or cross-site scripting, but that wouldn't have gotten us where we needed to go. So we Googled CSE, and it actually gave us another vulnerability that we didn't see before. So identification and all right. So and now we were able to run that exploit, and then because of that, we got into the server and we're able to read the files. All right. Identification and authentication failures. So authentication and session management constitute core components of web applications. Authentication is your username and password, gaining access with your credentials. Okay, that's how they're identifying you. They're identifying you by your username. They're authenticating you with your password, and then based on your level of access, that's your level of authorization. Okay, so when you log in, remember you'll get a token or you'll get a session cookie or something like that, and that is good for the duration of your session on that web app. All right. Where the vulnerabilities can come in is if someone were to either steal that session cookie, if the session cookie were weak or easily guessable, and they were able to guess your session cookie, if they were able to steal your password if you're using weak credentials, like if they were able to guess your password because you have weak credentials, if there weren't any rate limiting protections or like timeout or lockout policies, so it allows them to just keep brute forcing until they get it right. Those are all identification and authentication failures. Okay, so now this one is telling us to go. So we're going to try to speed through the rest of them. Well, not necessarily speed, but we want to we I want to try to make sure we finish the OWASP top 10 today. 248, and then we're going to port 8088. Then it says it wants us to register with the username Darren. Learn about attacking authentication. This room will focus on teaching the basics. Okay, so we're going to register. And it says the username is not Darden, Darren. Okay. Darren at example.thm, and then the password, we'll just do password. So now when we do that, it'll say not now. It says error. This user is already registered. So that in itself is a big no-no, right? It shouldn't give us this. This is known as verbose error messaging. So now what happens is the user is already, like you'll see when the user already exists. So it says, It says try to register with Darren as your username. You'll see the user already exists. So try to register with Darren instead. And you see they put Darren in quotation marks. Instead, you'll see that you are now logged in and can see the content. Okay, so now we're going to register. And now it says Darren. And then we'll just say Darren at example.thm. And then the password. So we'll hit that, and then we'll go here. Now the user has been successfully registered. Okay. So now if we sign in, we're going with our credentials. Oh, jeez. All right. So now we registered as Darren, and now we're logged in, and we can see content present only to Darren's account. Right. Okay. So now it says, oh, I'm sorry. We were supposed to go back and see the flag for Darren. Hold on. All right. Let's see where we are. Oh, were we not supposed to? Interesting. Why wouldn't it? Okay, but why won't it let me? There's supposed to be a flag here. Try this again. Darren. Email. Users already registered. Okay. Darren at okay, user successfully registered. There's no flag here, people. There's no flag. I don't know why there's no flag. All right. Okay, so we might end up having to, because I don't know why it's not letting us do that. Arthur at mail password. Users already registered. Okay, so we're going to try it again. Arthur at mail password. User successfully registered. Sign in. Fam, what is happening? Okay. I don't know. I don't know. I'm not sure why it's not working. I'm gonna copy this just like it said. Log out, register an account. Paste. Paste. Okay, I don't know. I don't know. All right, so we're just gonna go ahead and move forward. Actually, I think we're gonna go ahead and call it tonight, and then I'll just try to finish up Thursday because I'm tired. So, where are we? About 2.5 hours in. So, yeah, we're gonna go ahead and stop it here, and then we'll finish up with the rest of the vulnerabilities on Thursday. So I'm gonna go ahead and we're gonna stop here. Um, thank you for watching. Appreciate y'all. I played Web Goat, not too shabby. No, like I said, Web Goat, Matilda, and VWAP. Like I said, we'll probably look at all of those. Because I want to get that will be the next hands-on stuff. So yeah, I'm gonna go ahead and close up shop and get home. And y'all be safe. Like I said, tomorrow we have esports practice, so we will not be streaming tomorrow. Or if I do, it'll probably be a quick like gaming stream or something to kill some time after practice. But until then, like I said, I'll see y'all Thursday. Y'all be safe. And let us know in the comments. Like I said, let us know if you want us to keep doing these. If you want us to keep doing three, like I said, I'm thinking we'll probably scale back to maybe one or two a week real soon. But like I said, let me know what you think. All right. I'm going to get up out of here. Y'all be safe. Enjoy the rest of your night, and I will see you guys on Thursday.